What if I told you that coding didn't start with glowing green text on a black screen? What if it didn't even start with computers? For thousands of years, humans have been creating code, systems of logic and instruction hidden in plain sight. We're going on a journey to uncover the secret history of programming, a story written not in silicon but in stone, stars, and even thread. Forget what you think you know about technology, because we're about to decode the ancient world. When we think of code, we think of ones and zeros, of digital instructions. But the fundamental idea behind it, a set of rules to produce a specific outcome, is ancient. Think about the intricate patterns on a hand-woven rug, the precise alignment of a stone circle with the solstice sun, or the complex rules governing a social hierarchy. These are all forms of algorithms, ancient programs designed to organize, predict, and create. It's a mind-bending concept. Our ancestors were programmers, and their hardware was the world around them. This journey will take us into the forgotten roots of our technological age, revealing a past far more advanced than we ever imagined. Let's start in a place you'd never expect, a textile workshop. For centuries, weavers have created incredibly complex patterns. But how? The secret lies in the loom, particularly the jacquard loom invented in 1804. This revolutionary device used a series of punch cards. A hole in the card meant a specific thread was lifted. No hole meant it stayed down. Sound familiar? Hole, no hole, on, off, 1, 0. This was binary logic in action, decades before the first electronic computer was even a dream. These weavers weren't just making cloth. They were programming a machine using a physical, tangible code. The simple, elegant logic that powers our digital world today was first perfected not in a lab, but at the loom, proving that sometimes the most profound ideas come from the most unassuming places. Now let's turn our eyes to the heavens. Ancient civilizations were obsessed with the stars, and for good reason. The movement of celestial bodies dictated everything from agriculture to religious ceremonies. To track and predict these movements, they built what we can only describe as sophisticated data processing machines. Think of Stonehenge or the Mayan pyramids. These weren't just monuments. They were massive stone-built computers designed to run a single crucial program, the calendar. They processed data from the sun and moon to predict solstices, eclipses, and seasons. The lineage from these celestial calculators to our modern simulation software is direct and undeniable. They were compilers for the cosmos, and perhaps the most mind-blowing example is the Antikythera mechanism. Discovered in a shipwreck off the coast of Greece, this 2,000-year-old device is an intricate network of bronze gears and dials. For decades, its purpose was a mystery. We now know it was an astonishingly complex analog computer. It could predict the positions of the sun, moon, and planets, forecast eclipses, and even track the 4-year cycle of the ancient Olympic Games. It was a mechanical model of the cosmos, an algorithm made of metal. The Antikythera mechanism proves that ancient engineers possessed a level of mechanical and mathematical genius that we are only just beginning to fully appreciate. It's a tangible piece of a lost technological history. But code isn't just about machines, it's about language. The very structure of how we command a computer is built on foundations laid by ancient philosophers. Thousands of years before Python or C++, thinkers like Aristotle were grappling with the rules of logic. He developed the syllogism, a form of logical argument. For example, all men are mortal, Socrates is a man, therefore Socrates is mortal. Look closely at that structure. It's a primitive if-then statement, the absolute bedrock of modern programming. If A is true and B is true, then C must follow. This formalization of thought, this creation of a system where conclusions could be reliably derived from premises, was a monumental leap. It was the birth of syntax, the abstract grammar that would one day allow humans to speak to machines. So when you type a command into your computer, you're not just using modern technology. You're participating in a conversation that started in ancient Athens. The logical frameworks developed to understand the world became the frameworks we use to build new ones. Every programming language, with its strict rules, its operators, and its logical flow, owes a debt to these early pioneers of abstract thought. They were building the intellectual architecture for a digital world they could never have conceived of, proving that the greatest tool for innovation has always been, and will always be, the human mind itself. So how does this all connect? These threads of thought, the binary logic of the loom, the predictive algorithms of the astronomers, and the formal systems of the philosophers, didn't just disappear. They wove their way through history, directly influencing the pioneers of the computer age. Charles Babbage, the father of the computer, was explicitly inspired by the Jacquard loom for his analytical engine. Ada Lovelace, the world's first computer programmer, saw that this engine could manipulate not just numbers, but symbols, concepts rooted in formal logic. They were the bridge, connecting ancient wisdom to modern machines. And this legacy continues today. When we design artificial intelligence, we are essentially trying to replicate logical thought and pattern recognition, skills our ancestors mastered in their own ways. The neural networks that power machine learning are, in a way, modern reflections of how ancient societies observed patterns in nature to make predictions. The story of computing is not a short, recent tale. It is a vast, continuous saga. By understanding that the drive to code, to systematize, and to compute is a fundamental part of human history, we can better understand where we are now, and more importantly, where we are going. The echoes of the past are all around us, embedded in the very silicon that powers our future. Thank you so much for joining me on this incredible journey through time. If you found this as fascinating as I do, please hit that like button and subscribe for more deep dives into the hidden history of science and technology. Let me know in the comments which ancient code blew your mind the most. Until next time, stay curious.